Thanks for joining me today, Tsahi.
Hi, Arin.
Good to have you here as always. Today, we're going to have a little bit of an architectural discussion.
Okay.
As we know, as our viewers know, WebRTC can be used for a lot of different use cases, everything from one-on-one video calls to group video chats to streaming to larger audiences. Each of those different patterns requires different architectural decisions. Even within those patterns, there are many different ways you can do things depending on the use case that you're trying to do. So today I'd like to ask you for kind of like a high level view of a common streaming use case. So when you're having a video chat or a meeting, which you then want to stream out to a larger audience, which is kind of like what we do in WebRTC Live, right? So how would you recommend building a streaming application like that? What things do people need to consider?
So I guess there are two large blocks that you need to have there to begin with. The first one would be this meeting that we're having, me and you. That can be, one way, two way, in this case, 3, 4 people or more. That part is the traditional SFU, where you've got a media server, the SFU. It receives all of the inputs and then it just routes them around as needed. Okay. Now, the main difference from a meeting SFU to this one is that in this one, we don't really want everyone to be able to play with the layout. Only one person. In this meeting, that's you and not me.
Right.
You're the host, I'm the guest. Okay, so we're adding roles in here. And then there's another question that is being asked, and we being on a meeting, do we need to get the same kind of an experience as the end user or not? End user being the viewer on the other side. Okay.
So there's a third role there, the viewer on the other side.
Yes. So let's start with the viewer and then play with the architecture around that SFU that we have. We can start by saying, you know what? I want to keep this, I wouldn't say simple, but I would say I want the architecture to look simple.
Okay.
So I'm going to do WebRTC end-to-end. The live stream is going to be live as well, and not like 1-2 minutes delay or 5 seconds delay or whatever number you want to pick. And so what I can do if I want is to simply add everyone else into this SFU as viewers. So if it's me and you and 100 viewers, that can be on the same single SFU. We send the media between the two of us, and then the media is being sent from both of us to all of the others. So everyone in the meeting besides the two of us are going to receive 2 media streams and not one. The one from me and the one from you, and then locally, it's going to be combined on their browser. So they're doing it on the end side. Now, if we're there, I could say, well, you know what? So let's give them the ability to play with the layout if they want to. That would be a product management decision if that's something that you want to do in your application. But you have the ability to do that.
Right, because they're all using those SFU streams directly, connected directly into that SFU.
Using SFU
so they're going to get the individuals. Yep.
Exactly. Do whatever you want. Now, here's the problem. Let's say that I want 100,000 people to watch this stream.
Right.
This isn't going to fit on a single SFU. That is something that I can guarantee.
Right.
So what we're going to do there is start putting the, let's say, live broadcast kind of an architecture of WebRTC, where we're going to put restreaming servers in the middle that are also SFUs that get information from other SFUs and pass it along forward. It's more complicated than that, but this is like the way you need to build that. Some of them will need to actually be able to encode, okay, or transcode the video if they need to, because you can't have so many people on a single stream in WebRTC. Some of them are not going to be able to view. You need to reduce bit rates, packet losses along the routes, different things like that. Not a lot of vendors are doing that because it's not sustainable.
Yeah.
It will give you a live experience, but other than that, nobody cares. So when we're doing these things, or when I do my sessions, I use StreamYard, and then we stream to, I don't know, LinkedIn, YouTube, whatever. You put the link, and then you just forget about the fact that you send something somewhere. It will get there, usually at a delay of a few seconds, and again, nobody cares.
Yeah, in most cases, you don't need that live interactivity. You don't need the true real time for that.
Yes, I would ask questions. I will get answers or get questions a few seconds later. It's like, you go into this webinar or a session, and usually the host would say, "Where are you from?" He counts to 10, and then you would start seeing the results. And in between,
Right.
there is the filler, the gap, where you need to fill a few words before the first answer in the chat appears, because there is a delay.
Yep.
That delay is because we're switching from WebRTC to something else that is slower in latency. Not slower, but just higher latency. So then we take the SFU, and we then need to go and figure out how to take these multiple streams, me and you in this case, combine that on the server, and then send it out as a single stream, now not in WebRTC, usually over RTSP, to something else. Why RTSP? Because today CDNs know how to eat RTSP as an input, and then throw out on the other side HLS, MPEG-DASH, and all of the other acronyms that you need for streaming. Okay? It's also good if I want to use that thing to record, not to even stream. I want to record and use it later, upload it somewhere if I want to. So how do you do this mixing? Essentially, there are two general ways of doing that. The first one is take a browser, headless browser, Chromium, put it in the cloud using Puppeteer, or I have used this technology in the past, Selenium, okay? And then have that run as a client that nobody sees, but it is there. It receives the inputs, it outlays, it puts the display the way that you want it, and then do a screen grab on that, and have these screen grabs encoded into a video and sent over RTSP elsewhere, usually using GStreamer or FFmpeg. That would be one of the classic way of doing that. It's simple, it's straightforward, it doesn't scale well. It scales, but it's ugly because you need to manage Chrome entities. Yeah. The biggest advantage, you've got web technologies for all the UI. And it's easy to even test that because you can just open a browser and have that use it and see what it's doing, going with the inspector, play with it, and do the changes that you need. That's one approach. The other one is different. It's saying, well, I'm going to do the mixing on my own, using something else. Usually, again, it's going to be FFmpeg or GStreamer, but there's going to be something on top of that that allows you to build things. It's going to be more limited in a way, but more performant as well. You'll be able to scale it a bit better. It will eat up less resources of the machine, so it will cost you a bit less. So depending on how big and scalable you need the system, that might be a good approach. I would say that for the most part, that would be my phase 2 solution. Mm-hmm. So I would start with a browser, time to market, that's what I want. And then I would go with the sentence, if it's working, don't fix it. Just leave it as is. If you want to do the scaling, the optimization, or you've got some special need, then yes, go do the second option. It's a road that is a lot harder to do. Okay, so these would be the approaches there. Then there is a question, well, you know what? We want to also be able to have the recording after the fact. Mm-hmm. We go live and then we put it on a podcast somewhere, for example. So what do we do now? One option is don't change anything. You're recording and sending it out, just record and put it in a file. That's one option. The other one would say, well, do client-side recording and then upload to the cloud. And you've got companies that do exactly that. One of them is StreamYard. There are others. Most of them actually do that today. All of the ones that deal with recording podcasts. And they would, in parallel, record locally the files using a media recorder API. And then in parallel or after the session, they would upload the files and you'll need to wait before you leave. Yeah. The advantage of that is that, well, if I have packet losses on my side, that's going to kill the live, or it's going to be seen in the live session, but I can fix it later using the client-side recording that isn't affected by these packet losses.
Right.
So that would be another type of a solution that I would try to bake into it, if that makes sense to me to add that.
Yeah.
I think that covers most of it.
Yeah, no, I think so. I mean, definitely. So I think one of the most important things then for people to think about right up front, as you said, is what level of latency or is
Mhm.
acceptable, what level of interactivity is required for your use case. Because in
Yep.
most use cases, like what you and I are doing right now, where in this segment we're not even taking questions, we're doing this as a recording, latency doesn't matter, right? Even when
Yep.
we're taking questions, the relative, latency of just allowing for a pause in the conversation for questions come in is usually fine. But then there are a few use cases that, are definitely, these are more like edge use cases, I would say, but some scenarios where not only do we have to have real time, not just
Mhm.
low latency, but maybe even also synchronization of viewers becomes important to us. And maybe some
Soccer
like
games.
gambling, watching sports,
Yep.
maybe sensitive corporate announcements that will affect the stock market, things like that, right? There are some scenarios where those
Mhm.
extra seconds may really matter.
Yeah.
Those are unusual ones, but in those cases, if you can restrict everybody to being on that same SFU and have an audience size of 100 or less, then
You
that's
can,
maybe the simplest way to do it, right? But
yes. You can also do it with an SFU, and you can do it also with HLS, but that requires more, more technology to be baked into the solution.
mhm. Yeah, to make sure things are playing back at the same time across
Yeah.
that. Yeah, exactly. So lots to consider here. As always, the answer is it depends to a degree, but
Yep.
we've got a lot of flexibility in WebRTC and how we can architect it for these different kind of use cases. So as always, thanks for sharing your insights today, Tsahi. Appreciate it.
Thanks,
And for
Arin.
those of you watching live, learn more about Tsahi at bloggeek.me. And to learn more about future episodes of WebRTC Live, check us out at webrtc.ventures. Thanks, Tsahi.
Thank you, Arin.